Okay, so we're back at the next topic, which I started off by explaining a circle is an important shape. Now, its importance is not just because it's simple, it's elegant, it's beautiful, but its importance because it's very unique in the fact that it has two properties, which are really kind of the same thing. But the two properties are it has 0 sides, and the second property is it has approaching infinite sides. Now, I'm not sure if this is quite an original thought. I've heard the theory that approaching infinite sides is a property of a circle. However, to amalgamate and combine that with the fact that it also has 0 sides, I think is a new, perhaps important thought, if not misleading. So 0 and approaching infinite, the relationship between those two ideas and how we apply that to geometry is the subject of how I intend to spend some time in the future looking for ways and unique ways to chip into the field of math and make an impression or an indent in math theory and how math is thought of in math thinking. A lot of my strategy is to actually just vocalize my thoughts, but the idea of 0 and approaching infinite being a related concept in how the circle is identified, I believe could be important. Infinite sides is such that if we take a polygon and we apply an increasing amount of sides, we get a smoothed out circumference leading to the circle. 0 means 0 sides, which is an interesting idea in and of itself. And I would like to research the idea of 0 a little bit more, but right now it's more about just brainstorming and thinking creatively, which is what I like to do. So anyway, 0 sides is simple because we have 0 sides on the circle. Whereas approaching infinite sides is a bit more complex because we have approaching infinite sides. Once again, if a polygon is rotated and we have sides approaching infinite, eventually we get to the point, and calculus can explain this, where there is no such thing as a side anymore once you reach the point of that limit, of the approaching infinite limit. So on a graph, and I'm not even going to get into any calculus because we all know that, the point is, as you increase the number of sides, we're getting close to infinite and we're getting a smoothed out circumference. Notice how I say the word number. Now, number is paramount in revolutionizing geometry. Number. A related concept is what are the important numbers in geography? So we have 0, 1, 3, and 4, and I'm leaving out 2 on purpose. I say 1, 3, and 4 because 1 can be a number that's used in geometry. We have an apex, we have an intersection, we have 1 point, 1 side, or whatever. 3, there are 3 sides to a triangle. Simple proof. 3 is an important number. 4 corners to a rectangle, to a square, to any kind of 4-sided polygon. Not even getting into dimensional planes. By the way, 2-dimensional Euclidean or geometry is the root of interplanal and multiplanal physics, or 3-dimensional or 4-dimensional physics. So, and everything starts as a wave, everything starts as a line, or even a point. So what I'm talking about is 2 dimensions being prime and paramount in thinking about how we can reawaken geometry. Getting back to the important numbers 1, 3, and 4, 0 is an important concept as well. And I will just relate that the absence of sides can also be a great number of sides if you take the set 0 and approaching infinite. And I'm concerned about how 0 and approaching infinite are related. If we take other disciplines within math, we have the indeterminate equation of, say, 0 over infinite, or 0 over approaching infinite, meaning undetermined as far as I can remember. Actually, that would be 0. But the inverse would be, I believe, undetermined, if I'm remembering correctly. Because anything over 0 or a null set would be undetermined. So we have this special relationship in ratios and division of 0 and approaching infinite. The reasons why I'm saying approaching infinite are obvious if we study calculus, because one can only approach infinite. I'm going to go on for a couple more minutes and we'll wrap up at the 10-minute mark, because that is quite honestly enough. And I need to get some blood circulating. So this is a lecture, and it's not necessarily a point where we need to be writing down everything or coming up with a definitive proof or answer or theory right this very moment. But it's more about me sputtering what I believe are some important concepts that might lead to some kind of, hopefully, revolution. And, the stigma against thinking big in society is there. But listen, we're here to discuss ideas, and there's no limit to the size at which we can create our own ideas, theories, types of thought. So let's go back a little bit to 0 and the circle. So we have to think in terms of number theory when explaining the circle, or let's just say the circle or other shapes, the two other shapes that we've discussed. And the reason why we have to think about number theory is because graphs or figures just aren't enough to fully comprehend these important relationships. So it's going to go down to numbers clearly. So 0, let's focus on 0, 1, 3, and 4, and those numbers. And actually the nature of 0 in general, because my dad would talk about 0 being a concept that is important in philosophy and math and stuff. And, not honoring his legacy, but thinking about 0 could be an important toolkit as well. But for this point in time, we're going to consider 0 actually an integer. And I don't know if that's correct, but we're going to consider an integer along with 1, 3, and 4 in this discussion of numbers and how it relates back to the circle and other shapes, because number theory being prominent and precursing geometry, perhaps geometry is still a branch that we must utilize if we're going to shape things. I believe it to be useful. Okay, so anyways, focusing on 0 and 1, we would say that 0 is the absence of everything else. So it's the absence of numbers, the null set. So we think back to the circle, and we have 0 being the absence of sides. And this takes us into some uncharted philosophical waters, perhaps, but looping it back around, we must prove in essence how 0 can relate to approaching infinite in some drastic, abstract, yet perhaps provable way. And accomplishing this is not going to be a simple task. It's not something that we can do in this lecture. We have 1 minute left. But I just wanted to plant the seed and start about thinking about these relationships and how 0 can relate to approaching infinite, how the indeterminate set or ratio can get flipped around, inverted, and flipped around back again, and then inverted again, and how these can come up with undefined expressions, or perhaps even approaching infinite and beyond itself. Because what we need to do is really get to the heart of these shapes, 3 shapes that I mentioned, and how these shapes can be used to reverberate, recalculate, or redevelop how we think. So I'll leave that lecture there. We've gone from thinking to number theory to geometry to some lofty goals to how we're going to set about communicating. So I'm going to end our first lecture there, and we'll stop again tomorrow at around the same time, and I will implement the next phase in this lecture, which will go on to 10 lectures, each being 10 minutes. So thank you for watching. Bye.